InternLM-XComposer 2.5, also known as InternLM-XComposer version 2.5, is a versatile large vision language model that supports long context input and output. It excels in text-image comprehension and composition tasks, achieving capabilities comparable to GPT-4v with a 7 billion large language model backend. Trained with 24,000 interleaved image text contexts, it can extend to 96,000 contexts through rope extrapolation, allowing it to handle tasks requiring extensive input and output. The model features 3 major upgrades: ultra-high resolution understanding, fine-grained video understanding, and multi-turn multi-image dialogue. It also supports crafting web pages and composing high-quality text-image articles using additional LoRa parameters. Evaluated on 28 benchmarks, InternLM-XComposer version 2.5 outperforms existing open-source state-of-the-art models on 16 benchmarks and competes closely with GPT-4v and Gemini Pro on 16 key tasks. The model's architecture includes a lightweight vision encoder, a large language model, and partial LoRa for efficient alignment. It can process diverse input modalities such as text, single or multiple images, and videos, with enhancements for audio input and output using open-source tools. The performance of InternLM-XComposer version 2.5 is validated through extensive experiments, showing competitive results on various benchmarks. It surpasses open-source models on several video understanding and structural high-resolution benchmarks, and excels in multi-image, multi-turn understanding and web page crafting tasks. This model sets a promising direction for extending contextual multimodal environments, including long context video understanding and interaction history. InternLM-XComposer version 2.5 supports diverse input types, including text, single or multiple images, videos, and audio. This multimodality is achieved through several key components and strategies. Firstly, the Unified Dynamic Image Partition strategy allows the model to handle high-resolution images and videos. Images are processed using a dynamic partitioning method that scales the image to fit a 560 by 560 resolution for the vision encoder. This ensures that each sub-image has 400 tokens, making it suitable for high-resolution image analysis. For video inputs, frames are sampled and combined into a high-resolution composite image, with frame indices included to maintain temporal relationships. The model can also handle text and audio processing. It transcribes audio into text using Whisper and converts text back into audio using Ballots, enabling seamless audio input and output. The architecture includes a lightweight vision encoder, OpenAI L14, and a large language model, InternLM-27b. These components are aligned efficiently using partial LoRa, which fine-tunes the model for specific tasks without retraining the entire model. During pre-training, the large language model is frozen, while the vision encoder and partial LoRa are fine-tuned. This alignment ensures that visual tokens are properly integrated with the language model. Supervised fine-tuning further enhances the model's capabilities, allowing it to handle extremely large images and videos by training on data from diverse sources. The model can process a variety of input types, including single or multiple images, videos, and text. Each type of input is encoded and merged into a format that the large language model can interpret. The dynamic image partition strategy and vision encoder enable high-resolution understanding, while the text processing and language model handle language comprehension and generation tasks. InternLM-XComposer version 2.5 can also craft web pages and compose high-quality text-image articles using additional LoRa parameters. This functionality is supported by a combination of high-quality synthesized and real-world data, enabling tasks such as screenshot decode and instruction-aware web page generation. Overall, InternLM-XComposer version 2.5's multimodality allows it to excel in various vision language tasks by integrating advanced image processing techniques, robust text and audio handling, and efficient model alignment strategies. InternLM-XComposer version 2.5 can autonomously construct web pages using HTML, CSS, and JavaScript based on inputs like visual screenshots, freeform instructions, or written documents. Here's an in-depth explanation of how it works. Firstly, the model is trained using extensive datasets, including website version 0.1 and version 0.2, and Stack version 2. These datasets provide a variety of web page examples. The training process involves pre-processing HTML and CSS code by combining them into a single file, removing comments, JavaScript, external links, and unused CSS styles. Screenshots are generated from these files, and only high-quality web pages are retained for training. In the screenshot to code task, the model is trained to convert visual screenshots of web pages into HTML and CSS code. This process involves generating screenshots from HTML and CSS files, assessing their quality, and using high-quality examples to train the model. The training uses a LoRa model with a specific rank and batch size, following a learning rate schedule to fine-tune the model. For instruction-aware web page generation, to generate web pages based on freeform instructions, the model is trained using data generated from querying large language models like GPT-4 and Claude 3 Sonnet. This data includes diverse instructions and concepts for web page creation, covering elements like type, style, and layout. The model is fine-tuned with these high-quality, instruction-aware samples, often using Tailwind CSS for its succinct nature. In the resume homepage task, the model can generate personal homepages from resumes. This involves a pipeline where GPT-4 generates resume ideas for various personas, and these resumes are then used to prompt Claude 3 Sonnet to create corresponding homepages. JavaScript events are also generated to enhance interactivity. The model is fine-tuned on this data, ensuring the generated homepages are well-structured and visually appealing. Regarding the model architecture and fine-tuning, InternLM-XComposer version 2.5 includes a lightweight vision encoder, OpenAI ViT L14, a large language model, InternLM-2.7b, and partial LoRa for efficient alignment. During pre-training, the language model is frozen, and the vision encoder and partial LoRa are fine-tuned to align visual tokens with the language model. Supervised fine-tuning involves training with data from diverse sources, using a weighted sampling strategy. Finally, for preference alignment and reward modeling, the model uses reinforcement learning techniques like direct preference optimization to align generated content with human preferences. This involves generating diverse responses, collecting preference data, and training a reward model to refine the model's performance. This process ensures the generated web pages and articles are of high quality and meet user expectations. By integrating these components and strategies, InternLM-XComposer version 2.5 can effectively generate web pages from various inputs, making it a versatile tool for web development tasks. InternLM-XComposer version 2.5 handles video inputs and utilizes them for various tasks through several sophisticated techniques. Here is an in-depth explanation of how it works. Firstly, for video processing, the model uses frame sampling and concatenation. Videos are treated as a series of frames which are sampled and concatenated into a high-resolution composite image. This composite image represents the video by capturing multiple frames and maintaining the temporal relationship between them. Frame indices are included in the composite image to provide temporal context. Secondly, the model uses a dynamic image partition strategy. This strategy handles the high-resolution composite images created from video frames. The image is dynamically partitioned into sub-images, each processed by the vision encoder. The vision encoder used is the OpenAI ViT L14, which supports a resolution of 560 by 560 pixels, ensuring each sub-image has 400 tokens. Thirdly, the model processes both global and local views of the composite image. The global view represents the entire image, providing a high-level understanding. The local view focuses on specific regions or frames, allowing for detailed analysis. The unified vision encoder and language model are another key component. The vision encoder extracts visual features from the composite image. These features are aligned with the large language model InternLM-2.7b using partial LoRa, which fine-tunes the model for specific tasks without retraining the entire model. Enhanced resolution handling is crucial for the model. It is capable of handling ultra-high-resolution images, which is essential for fine-grained video understanding. The dynamic image partition strategy ensures that the model can process high-resolution images effectively, maintaining the quality and detail of each frame. The applications of video processing include several key tasks. First, video understanding. The model can analyze and comprehend the content of videos. It excels in tasks such as identifying objects, actions, and events within the video frames. Fine-grained understanding allows the model to capture subtle details and nuances in the video content. Second, video-based question answering. The model can answer questions related to the content of the video. By analyzing multiple frames and maintaining temporal context, it provides accurate and relevant responses. Third, video summarization. The model can generate summaries of videos, highlighting key events and important details. This is useful for creating concise descriptions or overviews of longer videos. Fourth, interactive video dialogue. The model supports multi-turn, multi-image dialogue, allowing it to engage in interactive conversations about video content. Users can ask questions or request information about specific frames or sequences in the video, and the model provides detailed responses. Fifth, video captioning and description. The model can generate descriptive captions for video content. This involves interpreting the visual information in the frames and generating coherent and contextually appropriate text. Overall, InternLM-XComposer version 2.5 leverages advanced image processing, high-resolution handling, and efficient alignment of visual and language models to process and understand video inputs. This capability enables it to perform a wide range of video-related tasks with high accuracy and detail. InternLM-XComposer version 2.5 introduces several novel concepts and applications. Firstly, ultra-high-resolution image understanding. The model can process and comprehend ultra-high-resolution images. This capability is facilitated by the Unified Dynamic Image Partition strategy, which allows the model to handle high-resolution images by dividing them into manageable sub-images, each of which is processed by the vision encoder. Secondly, fine-grained video understanding. The model can analyze video content in detail by sampling frames and creating high-resolution composite images. These composite images maintain the temporal relationship between frames, enabling the model to understand actions, events, and objects within videos. Thirdly, multi-turn, multi-image dialogue. InternLM-XComposer version 2.5 supports interactive dialogues involving multiple images. This capability allows users to engage in detailed conversations about visual content, asking questions and receiving responses about specific frames or sequences within images and videos. Fourth, web page generation. The model can autonomously generate web pages from various inputs such as visual screenshots, freeform instructions, or resumes. It uses a combination of high-quality synthesized and real-world web data to generate HTML, CSS, and JavaScript code, creating interactive front-end web pages. Fifth, resume homepage task. This task involves generating personal homepages from resumes. The model leverages GPT-4 to create resume ideas for different personas, and then uses Claude 3 Sonnet to generate corresponding homepages. The generated homepages are well-structured and visually appealing, enhancing content organization and aesthetic layout. Lastly, article composing. The model can generate high-quality text-image articles, including poetry, novels, short stories, and essays. This capability is supported by a scalable pipeline that integrates supervised fine-tuning, reward modeling, preference data collection, and direct preference optimization alignment, ensuring the generation of high-quality and stable responses. These novel concepts and applications demonstrate the versatility and advanced capabilities of InternLM-XComposer version 2.5, making it a powerful tool for various vision language tasks. In conclusion, InternLM-XComposer version 2.5 showcases groundbreaking advancements in vision language processing. With its ability to handle ultra-high-resolution images, fine-grained video understanding, and multi-turn, multi-image dialogues, this model sets a new standard in the field. The novel applications, such as autonomous web page generation and resume-to-homepage tasks, demonstrate its versatility and practical utility. Moreover, its capacity to generate high-quality text-image articles highlights its potential for creative and educational purposes. InternLM-XComposer version 2.5 is a powerful tool that bridges the gap between visual and language comprehension, paving the way for future innovations. Thank you for watching. Don't forget to like, share, and subscribe for more exciting updates on the latest in AI technology.